Hello everyone. So let's start solving today's problem, BFS of graph. So BFS is nothing but breadth first search, and it is a traversal technique to traverse all the nodes of a graph. And here we have to traverse the graph starting from zero. So the very first example I have already created here. So as you can see, this 5 indicates the number of nodes, and this 4 indicates the number of edges. Nodes is nothing but these circles. These green circles are nodes, and this edges, these lines, these arrows are called edges. So what we have is, in order to perform the traversal, we have to first create the adjacency list in which we indicate that which point is which is the parent node. So what I mean by that, it it is nothing but 0 can go to 1, 2, and 3. As you can see, 0 can reach out to 1, 2, and 3, and 2 can reach out to 4. So this is called adjacency list. So what I'm going to do is, I'm going to traverse all the first I'm going to traverse the very first node, which is nothing but 0. As you can see, it is given in the question that graph is starting from 0. So first I will traverse 0, then I will traverse on its children, which is nothing but 1, 2, and 3. Then I will move on to this one and check and visit this one, and then we'll check if it has any children. And if it one has any children, then I will visit one. Otherwise, I won't. Then I will move on to 2 and check if it is visited. So it is already visited since it was the children of 0. So I will check if there are any children of 2 which are not visited. So we have 4. So we will visit 4. Then I will move on to 3 and check if 3 is visited. Since 3 is a children of 3 is a child of 0, so it has already been visited. So our traversal would be like 0, 1, 2, 3, and then 4. Okay, so let's check. So as you can see, we are correct. And now let's implement this approach. So as you can see, I have used a queue data structure to store the nodes in FIFO fashion, which means that whichever node I insert first will be extracted, which is popped out the first. So for example, if the 0 had the children 1, 2, and 3, so 1 will be inserted first and will be popped out very first. Okay, so and I have taken a visited array to check if the node I have been visiting is already been visited or not. So initially I push 0 and make it visited. Then I loop until the queue is empty. And what I do is take out the very front element, which is nothing but the top element, which is present in the queue, and eliminate it. So let me try run. So it will be easy for you. So I have created a queue and initially inserted 0, right? And then I have marked 0 as true. So 0 is visited. So now what I did is, I have, until my queue is empty, I have popped out the first element, which is nothing but 0, and I have pushed it into my answer vector since I have to return the answer vector. So I have pushed 0 in my answer vector. Now I have checked if there are any children of 0. So for auto, I in adjacency of 0. So this is nothing but adjacency of 0 will give me 1, 2, and 3. So this will give me 1, comma 2, and 3. So since it has 3 children, so if visited of 1, now if we here we check that if 1 is visited or not. So 1 is not visited. So what do? We simply push this 1 into our queue, and then we may mark 1 as visited. Okay, so we mark 1 as visited. Then we move on to this 2. So we insert this 2 into our queue, and make it visited. So this is visited. Then we move on to 3, push it into the queue, mark it visited, and then there are no more children of 0. So we come out of this for loop. Then we move on to the next top element, which is 1. So we pop out this 1 and then we push it into our answer. So 1 is our answer now. And we check if there are any children of 1. So as you can see, 1 is a single node. So 1 doesn't have any children. Then we move on to 2. So this for loop for 1 won't be executed. So again, we move on to 2. Since 2 is the front node, we pop this 2 out and we push it into this answer. And we check if 2 has any children. So 2 has children, which is 4. Sorry, 2 has a child, which is 4. So what do? We simply push that 4 into our queue and mark it visited. So 4 is visited as well. So now there are no more children of 2. So we move on to the next front node of queue, which is 3. So we mark, so we push it into our answer. Okay. And 3 has no children. Then we move on to the next front node, which is 4. So 4 has been pushed into our answer and 4 has no children as well. So as you can see, the queue has become empty. So this line of code won't be executed and we return the answer vector. So our answer vector is 0, 1, 2, 3, 4. Okay, I hope you understood this problem. Thanks for watching.